So here we're starting out with this picture again. It's not the same video, it's a different one, but I want to tell you that we have places where we are going to both cross and touch the x-axis, but we don't know which one it is when I solve the equation, when I solve the function for its zeros. I can either be crossing or I can be touching. So that's when we start to understand multiplicity. So we come down here and we have this idea that says the multiplicity of 0 says if this is my factor, remember x minus r is my factor, and it is raised to any power, when the power that it's raised to is even, then the graph touches the x-axis, and when the power it's raised to is odd, then we cross. So if it's even, we touch. If it's odd, we cross. And that's what we're going to look at in these two examples. So we are given, in this first example right here, the function with these four terms for the function. And what I want to do is I want to find out what the multiplicity is for each of the zeros, and then I want to determine whether it crosses or touches. So how do I start? Well, in order to find out what the 0 is for the function, again, that's the real 0, we have to solve this function. Now, how do I solve a function that has four terms? First thing I'm going to do is I'm going to take it and I'm going to set it equal to 0. So I have x cubed plus 5x squared minus 9x minus 45 equals 0. Because I have four terms here, the way that I solve four terms is I need to group them. So I'm going to group these four terms and factor. Now remember that when I cut off this minus sign by inserting that that parentheses there, when I cut off this minus sign, I have to account for that inside by changing that sign there. Okay, now let's go back. Looking at this first set of parentheses here, what can I factor out that's common between these two terms? I can actually factor out an x squared, leaving me with x plus 5. Bring your minus sign down and look at the second set of parentheses. What's common here that I can factor out? Well, hopefully you said a 9, and that leaves me with x plus 5. So if you forgot to change this sign, that would kind of flush out down here. When we factor by grouping like this, you want this first set of parentheses and the second set to be the same. That's kind of the point. Now that I have this, I have two terms. Technically, I have a term here minus a term here. And we want to factor out the greatest common factor between these two terms. Well, the thing in common between those two terms is the x plus 5, or the set of parentheses. So x plus 5 factored out leaves me with an x squared minus 9 equals 0. So now I have my function fully factored, set equal to 0, and I take each of the factors and set them equal to 0 to solve. So x plus 5 equals 0, x squared minus 9 equals 0. Over here on the left equation, x is equal to negative 5. Here, how do I solve that? Well, the fastest way is going to be to add 9 to the other side. And now that I have a squared term equal to a constant, I can take the square root of both sides and find out that x is equal to a plus or minus 3. Okay, so what did we do? We found out what the zeros are of the function. But we need to now determine what the multiplicity is of each of those zeros. Going back to this factor for x is negative 5. This is the factor for x is equal to negative 5. What's the multiplicity on this set of parentheses? It's this factor is raised to the first power. Anytime when I'm looking at multiplicity, if I have an odd exponent, then that means, so the multiplicity is 1, and therefore this crosses at negative 5. Now let's go back and look at this factor. Although this is a squared term on the inside, the actual factor of this, or the actual multiplicity, I mean to say, of this factor is a 1. So this whole thing is really raised to just the first power. And that's what you need to be concentrating on. So we know that from this factor we have 2 places it crosses the x-axis at positive and negative 3, and because the multiplicity on this factor is 1, multiplicity of 1, then we are going to again cross at positive and negative 3. Don't fall for the fact that this is a 2 on the inside of your factor. Be sure that you're looking for the exponent on your parentheses, and that's going to tell you the multiplicity. Let's look at one more example together. Okay, let's see if we can go backwards. Here I want to form the polynomial if I already know what the zeros are that are given. Well, where do I start? I'm going to start by talking about these zeros. If I know that I have a 0 at negative 2, then in its factored form that looks like x plus 2. So this is the next 0, x equals 2. In its factored form it looks like x minus 2. And finally, when x is 3, then the factor of that looks like x minus 3. So the function, if these are the zeros of the function, then in their factored form it would look like x plus 2, x minus 2, x minus 3. So this is the polynomial function in its factored form. I might be asked to expand this form, and when I say expand or simplify, that really just means I need to get rid of all of these parentheses. To do that, you work in pairs. So I'm going to start here and I'm going to multiply these first 2 binomials together. Well, because this is x plus 2 and this is x minus 2, then that means this is a special product, and that gives me x squared minus 4 when I multiply that out, because that's the pattern that this follows. Now I would bring the x minus 3 down, and again, working in pairs, I don't have anything special here to multiply, so I just FOIL this. So this is going to be FOILed. X squared times x is x cubed. Here we have minus 3x squared. In the center we have minus 4x, and then last we have plus 12. So this is the expanded form of my third degree polynomial who had zeros at negative 2, 2, and 3.